Thank you so much for having me. I am, here as the seminar speaker or seminar instructor every week. So seeing me in a different capacity in my teaching sweater this time, giving a talk. And so I have been here at Westchester for quite a while and studying lead in the soil. And although I haven't been full time the last year and a half, still working on research. So, although I have given a presentation, a seminar on this a few years ago, and actually it may be now before most of the students' time, so maybe you haven't heard this before. But I've continued with this research, and we have collected some results in the past year. So I'm going to share the most recent findings and where the project is going. So I'm going to give you a little bit of background on lead and why it was used and how it got in the environment, and then talk about how we find lead in the environment, and then really get into the impact on public health. And that's, the whole premise behind doing this research is that lead is a dangerous toxin that has really horrible effects on public health. And then I'll get into the methods that I use for this study that I've been working on now for the past like 12 years. And from there, get a little bit into why Philadelphia has an even more entangled past with lead than other major cities. And then I'll show you some of our recent findings and get into a little bit of where the project is going. And I'll leave some time for questions as well. All right, so lead is actually thought to be the first metal ever smelted. So it was, found in artifacts dating back all the way to 7000 BC. And so lead was originally mined not for lead itself, but actually the mineral galena, which is a lead sulfide, was being mined for extracting silver. So obviously silver being a precious metal. And so silver is an impurity in galena. So the galena that was being mined was for the purpose of extracting the silver, but then it produced all this lead. And so as humans do, we found some uses for that lead. And so, the lead ores that were brought up, they were being smelted. And again, this was done, before we had a lot of the safety protocols in place. So the picture that's shown in the bottom right, of course, is just an artist's depiction, but it shows that, well, for one, you can see hopefully in that little picture there, the pouring of the silver. So they were, extracting that silver from the galena, but, it was done without any, real safety measures. And so as I'll get into, the workers were some of the first exposed people to lead, and therefore, were the first victims of lead poisoning. And so other uses of lead were found, more famously, the lead pipes that were used, to carry water during the Roman Empire. And so, those are a picture, that's a picture of some of the ruins from the Roman Empire that show the lead pipes that are still intact. Okay, so as I'll get into, one of the characteristics of lead is how durable it is. And so these pipes have survived for thousands of years. However, that durability is some of the reason why lead gives us the problems that it gives us. But the use of lead in these pipes has continued. So although lead isn't being used in pipes anymore for new construction, some of the older pipes that were used to carry water in various cities, of course, most famously Flint, Michigan, they still exist, they're still around, and they're still being used. So the lead use in water pipes is one of the more widespread uses of lead. So much so that the Latin term for lead is plumbum, and that was used to create this whole industry that's about water, about carrying water, which we know as plumbing. So plumbing is actually named after lead itself, because all of the plumbing that was originally created what was done using lead. And so this lead, this picture of the element lead and the PB, that's how we're familiar with the term plumbum, also shows some of the interesting characteristics of lead itself that I'll get into later on when I get into the results that we've obtained in terms of the speciation of lead that we found. But for and I'll say my recent and former geochemistry students. Now, if you look at this electronic configuration for lead that's shown there, what would you think would be the most common oxidation state for lead? And anyone can unmute themselves and, yell out an answer.
+2.
+2. Thank you, Chase. I appreciate that. And we know that because of this P2, this 6P2 that you see in the outer orbital of that lead. So the lead that we're finding the most is lead 2+, and that's going to be really important in terms of the various minerals that we're finding, these lead particles associated with, and also, the fate of the lead in the environment. All right, so lead 2+ is dominant, and we know that because of the electronic configuration. All right, and then we also get lead 4+, if you could see the 6P2, but also the 6S2 as well. So we get some lead 4+. These numbers on the side here give you all the oxidation states of lead. So although the 2+ is common, and we also find lead 4, there are various different forms of lead that are possible. And this is part of the reason why understanding the speciation of lead is so important, because it is so dynamic. And then some of the other uses of lead historically were also used in cosmetics. So again, some of those same uses continued, because we know that lead was more recently used in paint. All right. So, oh yeah, that's the configuration. I was supposed to circle that before. All right. So now the health concerns began to emerge very early on. And so this is really important, because pretty much if you look at the top text that I wrote and then the bottom text, there's a huge lag between, the time in which we realized that lead was a dangerous chemical and when we started to enact laws and policies to try to protect people, but mainly children, from that lead. So we've known about lead poisoning for a very, very long time. All right. So again, lead was used in pipes. It was also used in for eating utensils. So again, the paint, the glaze that was used contained lead. Again, it was very durable material. But this was a, very intimate exposure, right? Running water through those lead pipes and eating off of lead painted utensils. And so early on, there was the engineer Vitruvius who, warned all the people, and you can kind of imagine, screaming at the center of town about how dangerous lead was, but he was shunned and not listened to. And so one of the sort of delicacies that were enjoyed by some of the more affluent members of society was wine that was stored in these urns that again were painted with these lead glazes. And so lead actually creates a sugar. And so the wine that was stored in those urns had this slight sweetness to it. And so, people would enjoy that wine, and then they were seeing, the doctors or, physicians at that time were seeing a relationship between people that were drinking that wine and gout, which is inflammation in your joints. So again, there were, early signs that there were issues with lead. One of the other uses of lead is in bullets. You pump somebody full of lead. And so that was introduced all the way back in the 15th century. But of course, we know that lead is still used in bullets. And so there have been studies that have looked at game meat, right? So, meat that was, or animals that were hunted primarily with guns, and then studying the lead concentration from that meat, but primarily the people who are eating that, because it isn't from one animal. But if that is, common in someone's diet, if someone is a hunter and they like to hunt their own food, we're talking about that population of folks. And so they have shown higher lead concentrations in their blood from consuming this game meat. All right. So, but that is, again, a more fragmented part of our population. All right. So the two products that really exposed a wide portion, and really all of our population, to lead, were lead-based paints and leaded gasoline. All right. So those are the two products that sort of persist to this day. Okay, so the leaded gasoline, was introduced in the 20th century, but it was phased out by 1996. It was banned in 1996. So we don't use leaded gasoline anymore. However, we drove cars, and we drove cars everywhere. So I'll get into a little bit how that leaded gasoline has really been the point source. But again, we drove cars everywhere, so that source wasn't fixed, as was the lead-based paints. So lead-based paints were actually introduced back in the 19th century and continued through the 20th century, and they weren't banned until 1978. However, banning the lead paint didn't mean that all the lead paint was scraped off of every wall across the US. So again, that lead paint is still on the walls, on the interior and exterior of homes, even to this day. All right. So the interesting thing about the lead-based paint, if you could see in this image that I put up of the Dutch boy, he's riding a lead horse. All right. So that little horsey says lead on it. And so the lead-based paints that were, that were composed, that were made, became the favorable product. All right. Because they were, again, more durable than the other paints. They tended to not, wash away over time. And so they were promoted as the preferred type of paint. And then the same thing with the gasoline. All right. So the gasoline was, the tetraethyl was used as an additive to gasoline. All right. So the compound that was used was tetraethyl lead, and it was used as an anti-knock agent. If you could see that on this picture. So again, when that was invented, it was the preferred gasoline because it helped to maintain the engine quality over time. And so, again, those of us who are a little bit older remember going to the gas station and seeing the leaded and unleaded gasoline. So you actually had a choice of the type of gasoline. So the leaded was the preferred. And so what happens in your car is that the gasoline is, of course, combusted in the combustion engine. And then particles are formed from the various compounds that are in the gasoline. And so from the lead, at least some of the compounds that are thought to to form are lead bromides and lead chlorides. And so those are insoluble. And so, we're still determining the various products that were formed from the combustion of this leaded gasoline. But what we do know is that those products, again, they turned into aerosols, right? So they're tiny, tiny particles that were coming out of our tailpipes. So they ended up being deposited on the surface near the automobile. So again, that's going to be important when I show the urban versus suburban landscapes. All right. So again, we can just think intuitively that you're going to find more lead closer to the road in these soils because of the automobile driving down the road. All right. So again, that's pretty straightforward. So the lead is a resilient and durable product. And so it has persisted in our environment even since we've banned the last ban on lead being in 1996. But what's important to know is that we still actually use lead in the form of lead acid batteries, which we also use in our cars. Um, and so lead production is actually increasing, although it's secondary production. So using recycled products. And so, supposedly the lead is being contained through recycling of batteries. So that's why you should recycle your batteries. All right, so that lead can be extracted and then reused for more lead acid batteries. All right, so we use these two products, all right, and they were widespread in the environment. And so starting pretty much at the turn of the 20th century, in black is the leaded paint, the lead-based paints. All right, so they were used pretty extensively, and you can see that it began to decline kind of in the 30s. There's a pretty sharp decline there, but by the 1950s, they pretty much, again, they're still being used. All right, it's measuring in thousands of tons, so there are still values on here, but it's much, much less. And this is actually because the dangers of lead was already they were already being exposed. So although lead-based paints weren't banned until 1978, the product was being phased out in terms of its production. And again, it was because the industry already knew that it was dangerous. But many of those factories and plants were just repurposed. And that lead that was already mined and available was now being used for leaded gasoline. So you could see those two curves. As one goes down, the other one comes up. So in blue is the leaded gasoline. So the leaded gasoline gets used and really, really high quantities, especially from 1960 to 1980. All right, so a lot of lead got used, and again, that got phased out pretty quickly. So our time span of using lead in gasoline was short, but it was fast and furious. So there was a lot of lead that was used in those gasoline products during that time. All right, so from these two products, mainly the gasoline. All right, so this map is showing lead in aerosols across the major US cities. And so if you were to think about, because it's kind of hard to see individual, dots on here, but if the lead from the aerosol is related to gasoline, which city or cities do you think would be at the top of this list? And anyone can unmute themselves and shout out an answer.
LA.
Good. All right. So LA is actually number one, if you can see over here, on the West Coast, and it pretty much follows population, more or less, vehicular traffic, right? So LA is number one, New York is number two. I don't remember the exact order, but all the big cities are up there. We've got Houston and Dallas, you've got Atlanta, Chicago. Oh, yeah. So all of the big cities are up there. All right. And so our home city is not exempt. Philly is number 8 on this list. All right. So this is lead that presumably is forming from lead aerosols that are forming from gasoline combustion. All right, so directly related to how much gasoline was being used at that time. All right, so again, it was widespread. So now if you think of your own personal, residence and how we as individuals, as residents, as communities are being exposed to lead, there's two major sources, all right, for the average person. So for one, if there was lead on the exterior of the house, then then that paint would eventually weather and start to, actually deposit the paint, which could contain lead, into your soil. All right. So near the house, we tend to find a peak of lead in the soil, and, it'll drop off as you go further away from the house. All right. And then there's another peak, which comes from the road, right? From the cars that drove down the street with leaded gasoline in their engines. So there's a even bigger peak that is closer to the street. All right. So two peaks, one from paint and one from gasoline. Now, again, your house may not have been covered in lead-based paint. If you have a brick house, if you got vinyl, if your house is not older than 1978, all right. So if you have a new house, like, you're not even worried about this. Okay, so that's again more of a sort of point source, if that paint was used or not. But on the road, it really didn't matter. You couldn't control what your neighbors or folks in your city were putting in their gas tanks. So that leaded gasoline came down your street and past your house, regardless of what your personal choice may have been. But again, back then we weren't really told that lead was dangerous when these products were first put on the market. All right, we didn't know until much later. So those two peaks are going to affect the your yard differently based on where you live. All right, and the type of yard basically that you have. So in an urban environment where your house is most likely to be closer to the street, all right, this is measuring the distance in meters. So 5 meters. Listen, when I lived in Germantown in Philly, I think I might have had 3 meters, maybe two. I don't know. My house was like right there. It was like street, sidewalk, and then my stoop. So that 5 meters is generous for an urban front yard. But basically, you're going to see the convergence of those two peaks. All right, because you get the particles coming from the street, and then we've got this peak from the structure. So this peak hasn't had a chance to like dissipate, and then you've got this other peak from the house. Whereas in the suburban structure, as you get closer to the house, the amount of particles is going to just naturally start to decrease. So it doesn't mean that the lead wasn't deposited, but it may not be at your front door. And now thinking about exposure, thinking about the threat, especially with children, the distance from the street makes a big difference, because most likely if you've got kids, especially if they're younger, you're going to have them play closer to the house. So if you live in an urban structure, your kids are close to the house versus a suburban structure and your kids are close to the house. They've got different exposure, possibilities. So we see differences in these two environments just based on a very basic premise of these two different environments, right? Urban environments being less grass and having less space closer to the street. All right, so there's a greater threat in the city. And then just furthermore, there are more cars that probably go down the street in the city. So it depends, of course, that's all depending on, location. But really, really busy urban street versus a suburban street, we tend to see more cars on that busy urban street. All right, so again, there was more exposure there. And so from the paints, again, you basically see this is a graph that was looking at houses in Boston. So again, this is important because Boston is an old city like Philadelphia. All right, so older city, older houses, more likely to have lead-based paints. And so very, very simple concept. As you get closer to the house, there's going to be higher concentrations of lead in the soil when lead-based paints were used. All right, so they were looking at houses in Boston where there were lead-based paints used on the exterior. But the really important thing that I want to show you from this graph is the number that we'll remember throughout the rest of this talk, which is 400 parts per million, because that is the safe level set by the EPA. And that level is based on residential soil where children are exposed. So that's the baseline for all soils because you don't know when a child is going to be exposed. So we use that 400 as the safe level from here on out. And so what I see from this is that even with those 3 meters distance, right, about 16 feet or so from the house, the soil is still above that safe level. All right, so one of the issues that we see is that a lot of these urban environments are just sort of prime for lead contamination. All right, and that's going to have public health effects. All right, so now the third potential source are the lead smelters, the actual plants where the lead was extracted from the ore. And so in Philadelphia, and this is an image taken where we were able to collect samples, this was a site in green of a former lead smelting plant. All right, and this is along, if you can see, can't see that well, but this is Aramingo Avenue. So this is in like the Northeast Fishtown area, if anyone's familiar with that, Port Richmond neighborhood. All right, so so these are 2 samples that we took close to, you know, as close as we could get to those former lead smelting sites. All right, so there was a plant that was right there, and now this is, you know, these are residences we can see from the Google Earth image, all these row houses. The main thoroughfare, you know, these are businesses. That is a Rite Aid or some kind of pharmacy. I don't remember. This is a Wawa. You can tell Wawa even from space. But there's a Wawa there. So there's a lot of people moving around in this location. All right, even now. So, so again, the 2 main sources, paint and gasoline, expose, you know, pretty much our whole population. But then there are these smelting plants, and Philadelphia not just have, you know, didn't just have one, but had many, had several. All right, and so Philly became one of the cities with even more issues, but these issues exist for lead contamination all over the planet. All right, so in every major city, we see the same exact thing. All right, lead concentrations that are elevated, close to the inner city, close to the center of the city where you have higher vehicular traffic. So in New Orleans, you see from this sort of heat map, the elevated concentrations. Again, 400 is the safe level, and we're up at 1,000 in the middle of the city. All right, so bigger cities like New Orleans, smaller cities like Sacramento, this is showing the predicted concentrations. So they predicted to find higher concentrations in the city centers, but what they actually found was much higher. So they were expecting on the order of, you know, less than 200, but the circles indicate the actual concentrations, and they were finding, you know, twice the safe levels, you know, upwards of 1,500, right, in the middle of Sacramento. Sacramento is a pretty small city. All right, so we see the same issues in cities across the US. And then again, you know, it's a global problem. So the same thing in London, all right, where you get the higher concentrations that you see in red in the city center. All right, so we put lead all over the planet, pretty much. So now what does that mean? So very, again, intuitively, the more lead in the soil means the more lead that we're uptaking as human beings that live amongst these soils, right? In these soils. So this graph is showing lead concentrations in the soil on the x-axis, and then mean blood level concentrations on the y. All right, so a couple things to take from this. Again, positive correlation, the more lead in the soil, the more lead in the blood. All right, that's not too difficult to understand. But the level at which the CDC has determined is actionable. So the term is actionable. So it's not lead poisoning, but it's an actionable level, is 5 micrograms per deciliter. Okay, so 5 micrograms per deciliter is obtained at about 200, based on this graph. And this graph is, so the title of the, oh no, that doesn't pertain to that. This graph is actually from the study that's below, that's cut off, sorry. Because I was gonna say, that's not Australia, that's Detroit. So these are children in Detroit. So they're reaching a level of level of lead in their blood that is actionable by the CDC at half of the EPA recommendation. All right, so that's certainly a problem. All right, but the other problem is that the issue of lead poisoning didn't go away. All right, so this is a a map of Milwaukee, and it's showing children that had lead poisoning. All right, every dot on this map is a child with lead poisoning, and so the level that's determined to be lead poisoning is 10 micrograms per deciliter. All right, so that's twice the actionable level. All right, so actually the CDC had to come down because 10 was actionable and it was reduced to 5. All right, but 10 previously was the number. So this study is only looking at children that had 10 micrograms or greater of lead in their blood. But if you also look at the time frame of this study, they were looking at the time period after leaded gasoline was banned. All right, so the ban started in 1996. So they studied these children for 10 years. And what they found was that the kids were still getting lead poisoning, right? Because again, although the lead was banned in the gasoline and it had been phased out by the late 80s, you didn't see leaded gasoline anymore. That's something from like my early childhood that I remember, the leaded gasoline. This was from the lead still being in the soil that was deposited there from the last 30 years of use, that leaded gasoline. All right. So again, this was a 10-year study. This wasn't all at one time. So the graph, I mean, this image isn't as scary, but it's still scary. It isn't as scary. It's not a snapshot, but it's a 10-year picture of every child in Milwaukee that had lead poisoning, 10 micrograms per deciliter or greater. Now, we have to compare this to other cities because Milwaukee was number 26 on that map that I showed you earlier of lead aerosols, right, in the US. Remember, Philly was number 8, LA was number 1, Milwaukee was 26, and this is what it looks like. All right, so this is obviously, getting scary in terms of what does this mean for Philadelphia? What does this mean for the children that live in Philadelphia? All right, this is a problem. So now, when a child is exposed to lead, what does this look like? Okay, so lead is a neurotoxin. All right, so if I understand the biochemistry correctly, it interferes with the part of your brain responsible for decision making. All right, so you get exposed to this lead over, a essentially your lifetime. All right. If you live in this city and you're living in this environment, it doesn't mean that you're picking up the dirt and eating it every day. Maybe you did when you were 3, but as you grew up, just walking, through your neighborhood exposed you to the lead that would be in that soil. All right. So over a lifetime of exposure, this could result in increased incidence of violence, right? The child exposed to this lead, to this neurotoxin, and these graphs are showing, lead in blue, and then a 21-year lag, right? So you got exposed to lead, and then 21 years later, you made a bad decision and committed a violent act. All right. So there are studies that show these correlations between lead and violence. All right. And then this study was done in Australia, looking at different cities and different exposure rates, but just overall tracking that relationship. And so similar studies were done in the US. All right. So the image on the right, looking at, the same sort of trend in various cities in the US with high crime rates, Chicago, Atlanta, New Orleans, and we see the same thing. Some of the other effects of lead poisoning is, effects on learning. So the image in the middle is showing the relationship between lead in the blood and IQ points, right? Like your innate intelligence, not your learned intelligence. All right. So, well, the first thing they're basically telling us is that we've gotten smarter. So I guess we are smarter than our parents, because the average IQ in 1976, where children were exposed to lead. So of course, looking at populations of children that had experienced lead poisoning. And again, these are young children under 6. All right. So at this 10 microgram per deciliter, where lead poisoning begins to take place, right, is a lower IQ, somewhere around 7 or 8 points lower. And as lead got phased out of the environment, then we see less effect, right? IQ went up. All right. And then apparently there was a study that linked lead poisoning to teenage pregnancies even. And I'm like, okay, well, I don't really know enough about that. There may be some other factors, but the point is that exposure to lead for these children at a young age and over their lifetimes has affected, their lives, affected the decision making that's happened because of being inundated with this neurotoxin. All right. So this is obviously, again, a public health concern, because these issues don't just affect the kids that are being exposed, but they affect us. Violence affects those of us who may be innocent, right? A dumber population, I didn't say dumber, they said dumber in the study. A dumber population affects all of us, right? Teenage pregnancy affects all of us. So these are public health concerns. All right, so all these words to say that that lead is dangerous, and so I wanted to study it. So first, what I did over like the first, maybe half or so of my career at Westchester was to measure lead in the soil. So with various students, we looked at various parts of Philadelphia to get an understanding of how much contamination was out there. And now my secondary objective over the last few years has been to study the characteristics of that lead and try to understand what the public health effect is, how bioavailable is the lead. We get that from the characteristics of lead. All right. And so again, the communities that we see affected most by this lead poisoning tend to be lower income communities and minority communities where there are, black and brown populations. All right. So these are issues, again, that are particular to Philadelphia because of not just the 2 sources, but 3 sources that we see in Philly. All right. So various samples were collected throughout Philly and even Westchester. and worked with just a number of undergraduate and graduate students for various projects. Like students were looking at different aspects of this problem over the years. Um, and so the first method we used was the XRF, which I'm going to show on the next slide. And from there, again, we've studied just like maybe by now hundreds of samples. Um, but luckily, only the really elevated concentrations were found in just a few samples. And so those samples we've continued to study, and that's what I'll be focusing on towards the end. So the XRF, our famous instrument that not only I use, but many of us use in the department. And I won't get into all the details because I want to get to more results. But the cool thing is that it's portable. So that's just showing me at a farm in Philly using the XRF on a compost pile. Um, and I also did a lot of community workshops throughout Philly at different farms and growing spaces. And the reason for that is, we're talking about the impact of lead on the community, but what also has been emerging is urban agriculture. And as many of you know, the reason for my career shift has been that I've become a farmer and have a farm in New Jersey. But before we were in New Jersey, we were in Philly. My husband worked at a farm in Philly, and so we were connected with that urban agriculture population. And so I was really interested in how lead was being taken up by various crops that were growing and just the impact on agriculture in cities. So one of the graduate students that I got a chance to work with, Tim Martin, a few years ago, back in 2015, he looked at the lead smelting that took place in Philly. And so, that River Wards area of Philly, which is up here in the Northeast, is where we see a lot of the lead smelters. But there were some that were just like splattered all over the city. And so, again, at one time, Philadelphia had the most lead smelters of any major city in the US. All right. So, again, Philly has some particular issues with lead. Another student, Zach Schwartz, did a GIS project. We looked at the lead concentrations and mapped them. And so I was curious to see the lead smelting sort of impacting the concentrations. And so we see where some of the smelting is responsible for the elevated concentrations, but maybe not able to explain all of the elevated concentrations. And that was important because a lot of the attention that Philly has gotten has been in these river wards communities where there were these lead smelters. So the first set of studies, the first set of samples that we analyzed, and I call these semi-qualitative because we did these in the field, and they just kind of gave us an idea of was the soil contaminated or not. And so we saw at the one site at Overbrook, where there's like 1,000 parts per million, and that was close to the house, we could literally see the paint chipping off of the building. And that house was over 100 years old. But where we saw 3,000, parts per million was down here in the River Wards in Port Richmond. All right. So that was like the first study that we did way back when, 2010-ish. And from there, we just continue to find different ways to try to understand this lead. So working with another student, James Reiners, and we did an XRD study. And we were able to find a compound that was very similar to tetraethyl lead. It was a lead tetramethyl heptane, which was some byproduct of combustion. And so that was actually from one of those Port Richmond samples. And so now more recently, I've been able to collaborate with some other scientists. So most notably, Michael Schindler, who is in Canada. When we first met, he was at a different university, but now he's at University of Manitoba. And so he's done some detailed, ICP-MS studies where we've been able to get some isotope analysis as well as more detailed concentrations of lead as well as chromium. So I'm just going to go through these results so we have a few minutes for questions. But we've been able to see elevated chromium concentrations. So in this first image here, so the 0 sample is a sample from Germantown that I collected, and this was actually in someone's yard, and it's 5,000 parts per million. So pretty scary. This Germantown set of samples that I took, because I found that measuring it in the field, and I sampled the hell out of my friend's house. This was my friend's house that she had just bought. So I have like so many samples from there because I said, whoa, this is crazy. So so the first sample, the sample 0 is the one that's close to the street. And again, it was our indication that we're getting these concentrations from gasoline. But I got more samples going sort of toward the house and then in the backyard. And we compared these to the other elevated samples, the one from the river wards from Port Richmond, and then another one that we detected had the lead paint. So we wanted to understand the relationship between lead and chromium because we saw elevated chromium levels in some of the samples. So definitely see a trend there. And then the isotopic analysis has been really interesting. So again, I know I don't have a whole lot of time left, but what we're seeing is that there's a trend with these samples. So kind of looking at the lead 206, 207 to lead 206, 204, the image that is in the top right, there clearly looks like there's a trend which shows a similar source of this lead. But then those other 3 samples seem to be off a little bit, samples 2, 6, and 7. And so those samples, at least 6 and 7 were from a different location, where sample 6 is the smelting sample. And then in the lower left, the plot of lead 206, 207 to the lead concentration, again, the smelting sample was sort of out of the range a little bit. So clearly indicating that there's some difference in the source of that lead. And I will say that these results are sort of hot off the presses. We just got these within the last couple of weeks, and so we have more samples out. So we're still in the process of like literally analyzing these results. This was an older image of SEM from Tim Martin's work, but that led to me continuing to look at that sample. I did some analysis at Virginia Tech, and the point of these is just to show sort of what I mentioned here, which is that there's greater concentration in the finer particles. So that led to doing more mapping of these samples and trying to understand what the mineralogical composition of this lead is. What are the associations? All right, so in these last few images, so the lead is in red, and I made the lead red so I could say the lead was in red. So the lead is in red, and we're seeing some associations with chromium. Again, we saw that association, but now we're seeing physical evidence of lead and chromium being related. And so from that, we took a focused ion beam sample to use for TEM analysis. And again, not getting too much into the methods, but more the results. So the TEM that we've gotten so far, which has been very limited, was identifying this crocoite. I hope I'm saying that correctly. You guys know I'm not a real geologist, so somebody can correct me if I'm not saying that right, but the crocoite is the lead chromate mineral. And this was like a huge finding because not only is it chromium, but we're realizing it's hexavalent chromium. This is the scary Aaron Brockovich chromium. And so it was like sound the alarms when I got this email about a month ago. So literally, this is all just like brand new, fresh information. But we did have some problems with our samples. They got contaminated with copper and all kinds of stuff. So I had to send more sample out last week, actually. And so they're undergoing more analyses right now, maybe as I speak. The other thing that we found was a lead phosphate mineral assemblage thingy, which we think might be a pyromorphite sort of sample. So something that is a lead phosphate mineral, which is analogous to apatite, right, to the calcium phosphate. And this is important because of the solubility of that mineral, and it may be able actually to sequester lead from the soil. So that may indicate some other behavior that it may not be as bioavailable as we originally thought. So again, we're trying to get another extraction from new samples to get more analyses. So in conclusion, Philadelphia has, all three major sources of lead. We definitely found elevated concentrations. And so far we're seeing evidence of a lead chromate, particularly a, chromium 6, the hexavalent chromium, which is the really nasty stuff. And we're seeing evidence of lead phosphate minerals. And so again, all of this is going to impact the bioavailability of the lead that we're finding. So knowing the concentration of lead is important, but also knowing the phase is important because that's going to determine how it behaves. So again, we're undergoing these studies literally right now. So I'm actually working on developing a project with the nonprofit that I started this year, Freehaven Institute for Science and Agriculture, to work with high school students from these neighborhoods where we're collecting these samples to get more community involvement, to increase diversity in geosciences, and to get more samples in various neighborhoods. And the kids that live there would be perfect candidates to study their own environments. So ultimately we're trying to get more information so that we can better impact policy, not just in Philadelphia, but in every major city where lead contamination has been a problem. So lastly, just want to thank everybody, thanking my family for even inspiring this study. My husband doing the agricultural work is how we even got involved in, or how I got involved doing this lead research in our first backyard in Germantown. And then all of my collaborators from obviously right here at Westchester, but my more recent collaborators up in Canada and also at Virginia Tech. And all the various students I've worked with at Westchester over the years. So thank you guys, and hopefully there is time for questions.
Thank you, Cynthia. It was great talk, and then lots of information from the basics to all the application side. And student, as you heard, you might have chance to work on those kinds of data and then more analysis. Before that, any questions for her?
I don't have a question, but I did have a comment. I just wanted to say that I always love hearing the work that you do, Dr. Hall, because for me, at least personally, I've always loved chemistry, and geochemistry has always been something that I've really been fond of. So it's always really nice getting to see what you're doing. And I thought it was a very nice talk. So thank you for sharing this with us.
Thank you so much, Chase. I appreciate it.
I have a question, Dr. First, I want to, not that we all know I'm not a chemistry fan, But I do really appreciate this work. And I grew up and live in still the Philadelphia area in neighborhoods just like the ones that you described. And it's important to do this research and also to make people aware of the exposure, because most people think that was something that was only a problem back in the 70s. It's not a problem today, but like you said, lead persists. So if there is anything that I can do or any of us students can do, just let me know. I mean, what can we do to help make people aware and to find out what's going on in our own neighborhoods? Because like I said, I still live in the Philadelphia area. So, and I don't know of anybody else besides you that's doing any sort of research in this area.
Yeah, no, thank you for that, William. I appreciate it. And you were in geochem last semester, is that right?
Yes, I was.
Yeah, so I don't think you got to collect samples, and so that would have been just a perfect collaboration because you're in those neighborhoods. So but hopefully, you know, in the future, maybe by the summer, I'm hoping to get the next phase of sampling going by the summer. So we, you know, I would love to, you know, reach out and be able to.
What's an XRF going for these days?
Oh, you know, cool 50K, you know, no big deal. But I know we've got our Bruker, man. We've got our Tracer 3 that's still up and running, and like I said, a bunch of us are using it. You know, I know Dr. Humke uses it, and Dr. Nicotina's used it, and so a bunch of us use it, and it's still going strong. So yeah, hopefully in the summer, I'll be able to get out there with the students at the project that I'm developing right now, to go into more neighborhoods. So that would be a perfect opportunity to be able to go to your neighborhood.
It's not a field trip for me. I mean, I don't have to even drive anywhere. So just let me know.
Yeah, no, thank you. I appreciate that. Getting access to space is always an issue.
I'll find access. Don't worry about it.
Yeah.
I'm from Philly. We get access.
That's what I know.
Thank you.
Any other questions, comments?
If you find an area that has a dangerously high concentration of lead, how do they clean it up?
So that's a good question. You know, for large areas, especially if it's, you know, more of a public space, you know, it can be deemed a Superfund site by the EPA. That doesn't mean it's going to get cleaned up right away, but it just means it gets put on the long list of other Superfund sites. But it, you know, means that some federal aid will come to help clean that area up. But most people's backyards are not going to be, you know, not going to have that ability to get Superfund status. So in the case of like these yards in Philly, for example, where I've measured really high concentrations, I mean, a couple things can be done. You know, you can take all the dirt out of your yard and, you know, send it to the landfill somewhere. That's probably not realistic. It's going to cost a lot of money. So a couple of things. The most important thing is to keep soil covered. So the exposure happens when the soil is bare, and especially if, so the biggest sort of method of exposure is soil that's converted to dust that gets ingested, right? And that happens when the soil is bare, especially when it's very dry, and the wind picks up that that dust, that soil, again, turns it into dust, and we ingest it. And that's how people are able to be exposed just from walking in their neighborhood, just from living in this place. Of course, the most, you know, risky behavior is actually being in that soil. So again, we picture the child in their backyard playing in the dirt. So in the case of a lot of soil testing that I've done is usually people who say like, I want to grow food in my yard. Again, because I have that connection with growing food. So in that case, I always say, you know, you need a raised bed, you need to be able to cover the soil. So it's actually more, you know, it's an advantage being in Philly and having a very small yard to be able to say, like, we can actually cover this whole yard in like plastic, getting the rolls of plastic from Home Depot and covering it. So like almost a cap and fill, but doing it yourself at home. Um, and then putting some new dirt on top of that. And again, you can plant grass in there now or plant some crops that you actually want to eat. But just creating a barrier between you and the soil is the most important thing. Um, so even if it's just planting grass in that contaminated soil, that's going to decrease that exposure because it won't get picked up by the wind as easily if there's grass growing in the soil with some roots.
Thank you.
Mm-hmm.
Hey, Dr. Hall, I also had a question.
Yes.
Hope everything's going well for you, by the way.
Oh, thank you.
Yeah, but yeah. So when you said that, like the drier conditions and the dust is getting kicked up, I immediately thought about like the dog days of summer when I was like in a football camp, and I just was asking if you have heard of any like fields or like that like teams practice on that could possibly contaminated with lead, because I just thought like that would be a like a really easy way to get exposed to it if you're having like a team practice on a field that is like contaminated with it, you know?
Yeah, no, absolutely. So there's studies that have shown the like seasonal trends in lead poisoning, and they track the dry summer. So they say the third quarter. So, you know, late summer when it's dry and hot. And so, you know, the soil is going to be really dry and it's going to be really susceptible to getting picked up by the wind. And so you're increasing the exposure during that time. And what's happening during late August is definitely it's football camp. So there's, you know, guys are out there running around on that dirt, or just even if it's not an organized camp, again, kids playing in the park. So definitely, it is a source of exposure. There are parks, public parks in various cities all over the US where I've seen those signs that they put up of like lead contamination, do not play on this in this park. So so it is a big problem and it still persists. And again, because we haven't measured every single park and every single yard in the United States, we don't know where those places are. Um, so there's the potential. I mean, it's definitely the high, you know, risk for that exposure during the late summer. So that image in your head was, you know, it probably was there because that is a common way where that lead poisoning is happening.
Yeah, that's all I could picture when you said like dust getting kicked up and everything. And I just think about all the years I was out in that.
No, I mean it like I said, it's been a problem and still even to this day, the graph that I'm thinking of is a study that was done in Flint, Michigan. So it was basically showing that this lead contamination problem was there in Flint even before the water issue took place with switching the drinking water to the Flint River and running through those leaded pipes, because the water contamination issue is completely different from the soil contamination issue. And the whole source, the whole premise is completely different. Again, the lead pipes is how we get lead in our drinking water, and then the lead in the soil is a whole separate issue. And so basically it was saying in that paper that there was already a problem in the soil, and then we just added to that with the drinking water problem. And so yeah, those factors are there in most environments. Again, Flint isn't like a huge city, it's a very small city. Um, but you still saw the lead contamination in the soil and elevated blood lead levels that they were measuring in children during the late summer. So they know that that was a high time of contamination and therefore, you know, poisoning those kids.
Very interesting.
Okay, so it's over 5 p.m. So let's have one more final question for official seminar, and then we will call the seminar, and then we could have more time to chat with Dr. Hall. But is there any final question or comment?
I got one.
Go ahead.
So, like, you know how in your presentation you were talking about how there's like a trend in like between lead contamination and violence in like the inner cities? Like, would you think that there was like probably a lot of like lead smelting plants in like North Philly and West Philly?
So yeah, a lot of the lead smelting plants were in the Northeast. But those studies were shown in cities all over the globe. I mean, that first set of graphs was from Australia. And so it's not necessarily the lead smelting. It was, again, I think the real danger was the leaded gasoline because we drove cars everywhere. We drove cars in suburbs, we drove cars in rural areas, we drove cars in cities. And so that link between lead poisoning and violence, was, I think, the potential for that, remained regardless of the type of exposure, whether it was smelting or gasoline. So again, we see these in we see that relationship in areas even where there weren't a lot of smelters. But again, the areas that have the smelters have even more, elevated concentrations and even more lead poisoning. So yeah, probably those neighborhoods where you have the smelting, you're going to have even more violence.
Yeah, maybe there were also like high congestion, like areas with like traffic with cars with leaded gasoline too.
Yeah, definitely. And that one study they showed in New Orleans, one of the busy intersections in the French Quarter, and there would be, upwards of 10,000 cars that went down that street every day, every day. So that's a lot of exposure. So again, thinking of that, if you live on that street versus living on a street in the suburbs where maybe 50 cars go down your street. We live now on a dead end street. It's just me and my one neighbor, I mean, in the trash truck. Like, so that difference in exposure, I think, again, plays out in some of the effects of lead poisoning that we see in these different areas.
Dr. Hall, do we know there's any difference between the lead compounds and the health effects? I mean, certainly the hexavalent chromium is especially dangerous, but the exposure from lead from gasoline seems to be the more dangerous to me, just because of all the other compounds that are mixed up with it than straight lead from smelting, right?
Yeah.
And it's certainly more widespread, prevalent, right? And I don't know if any of these studies have drilled down into what types of exposure these people were, because it's just lead exposure. I mean, as far as I could tell from that chart, it's lead exposure and neurological issues, right? So I don't know if anyone's ever drilled down into get to the nitty gritty of what exactly was their exposure, what was the source, and what kind of compounds were involved in it.
Right. Yeah, that is kind of compiling all of the various studies together. And I haven't found a study that linked all those things. I'm just getting this information on the type of lead. But I think that there could be correlations because the lead, the pyromorphite, I think that's the one, the lead phosphate mineral, the fact that it's similar to apatite. And what I wanted to kind of get back to with that oxidation state thing is that the lead in the lead 2+ is similar to calcium because calcium is in 2+.
Right.
And so I recently was, this was actually during a farm tour, so it was in my other life, but I met a guy who was a doctor in Baltimore, and he was saying that they were studying lead in the bones of children. And that was one of like the huge issues that I was finding was that if the lead is similar to the calcium, wouldn't our bones take up the lead in our teeth, and that would sort of prolong our exposure? Because normally when we look for lead, we look for it in the blood. But I think that that could be, your blood is going to like, recirculate, and you could, after time, because usually what they see is exposure, the lead in the blood is high, and then they do some treatment, and then the lead, decreases in the blood, and now everything is fine. But if we're storing it,
Yeah, if
because
you're storing it in your bones, that's
calcium,
not, that can't
right,
be good.
if you're storing it in your bones and it's in some form that's similar to apatite looking mineral, then we could just have these lead deposits in our bodies that would slowly maybe solubilize and like poison us slowly over time. Who knows? But I want to understand all those interactions as well.
Yeah. Yeah, that's you can do that next. Work on that next. Now lead persists, right? There's no plants we can use to uptake lead, is there?
There are.
What-
That was Catalina Rivas's project that she finished just this summer. So there are plants that do phytoremediation. So they take up, various contaminants. And so there's some that will extract lead. So mustard greens, so the mustard plant, and sunflowers are the two that at least we were studying. She couldn't get her sunflowers to stay alive. So her pieces only like looked at the mustards because we kept those alive. But there are other plants as well that have that ability. I think cilantro has the ability to do that as
These are
well.
all food plants, though. That's not necessarily a good thing. We don't want people eating this after it takes up the lead, right?
No, definitely not. The sunflowers have been used in various city projects in terms of like beautifying the landscape and cleaning the soil. And the concern with that always comes up during those talks is always, well, what about when the sunflower seeds enter the food chain from the birds?
Wow, yeah.
Because
Yeah,
we're
yeah,
not
yeah.
going to eat the sunflower. Well, maybe you would extract, but if you're planting them for the purpose of phytoremediation, then you wouldn't eat those
Yeah.
seeds. And you wouldn't eat
The lady down the street from me, actually, she grows a whole crop of sunflowers every year. I don't know what she does with the sunflowers. I got to ask her.
yeah.
She's got one of those little urban farms. I mean, she's got one of them little, little tiny plot of raised beds on a property where there used to be a house that burned down, when I was a little kid or whatever.
Yeah.
Yeah, but she's got a little farm there, and she grows sunflower seeds there every year, every
She
summer.
might be growing them to help
Clean up the
clean
soil.
her
Maybe
soil.
I'll ask. She seems like she might be that kind of person.
Yeah. And if you're in, that part of Philly, folks have known about that lead
Oh
in
yeah,
the Northeast. And that was the thing when I went there and just talking to people, they're like, oh yeah, we got lead in our soil. They know.
yeah. They know. Well, there was lead in the houses. I mean, every house in on those Philly row home streets were painted with lead, so they were all made aware of it.
Yeah.
It's not like they stripped and every house in Philadelphia. I mean, the whole place was coated in lead at one point.
Yep. So no, you definitely can use those plants, and I think
We
that
grow them, we
sunflower,
harvest them, and what do we do with them?
throw them away. You have to bag them and
Landfill.
landfill them. Yeah.
Does that get back into the groundwater when you throw things into the landfill? Is that an issue?
Yeah, I mean everything, but if it's over there now. It's their
Not in
problem.
my backyard.
But
Yeah. It's better than kids playing in it, right? I
yeah,
guess.
yeah.
That's
it's,
good. Good to know.
and again, the sunflowers, if you're growing them for the intention of cleaning your soil, then you sort of will deal with them, appropriately.
Yeah.
But I've seen areas, that one spot, the picture I showed from the workshop I did, it was actually a girls' camp in Philly, and they had planted sunflowers there for years, like for 20 years or something. They planted them for that reason, and that soil was like pristine.
Really?
Yeah, and that was in North Philly.
We should do a before and after kind of study of.
Well, that was what Catalina's project did.
Is it?
Yeah, and she showed, I mean, it wasn't like highly conclusive, it wasn't,
Yeah.
she wasn't able to do multiple iterations, which you would really need, but she showed promising results that, look at the lead in the soil before you plant the thing, and you look at it after, and it's less. All right, that looks like a
That's
win.
good enough for the homeowner, I'm sure.
Yeah,
If not for your scientific research, it's good enough for the person who lives there.
yeah, it's a viable solution that's,
Yeah,
you know,
absolutely.
it's like doable. So.
That sounds like good work, man.
You think lead might have like played a role in like, you know, like the protests in Philly, like turning violent and becoming riots and stuff?
No, I mean, not directly.
That was probably systemic racism that did that.
More like it's the social effects rather than can't blame everything on lead, or I would blame it on much more in my life.
Right,
Oh, no, I think they went a little far though. That's the thing. They went a little crazy. They're lacking common sense, you know.
Yeah, no, I mean that's. I hear you, brother.
I totally get that. It makes perfect sense, but
that one graph on the teen pregnancy, and again, it shows it like decreasing in the 90s, and I was like, well, they did start putting condoms in schools and stuff, and like sex education. So, I don't know.
There are a lot of factors you could weigh, you know. But poor judgment, I'll go with that. I'll go with the poor judgment. I've seen people's judgment decline significantly since the 70s.
Cynthia, great presentation. We enjoyed it. And I have to run. Sorry. I'll let you continue on.
Okay, I wanted to show you something.
What you got?
I won over the weekend.
Oh, God, congratulations, man.
45-minute nitro buggy A main.
Wow.
I was racing for 45 minutes straight.
Congratulations.
In like 37-degree weather.
Not with leaded gasoline, right? That's nitromethane.
No.
Okay. Okay.
No.
Good. I got to run. I'll take care. Thank you, Cynthia.
Martin, good to see you.
All right. Thank